So I'm going to do an example of this one right here, and hopefully this will help. All right, so we want to use Jefferson's method. We have these 5 counties, and we have 31 seats to apportion. So I've moved this over, and since you're having trouble with the, move this over here. There's all of our initial information. We have 31 seats, and I put it down here. And so hopefully you're doing the first steps exactly the same, which is to add up your populations, which adds up in this case to 1,253,000, and we want to divide by the number of seats, 31, which gives us a standard divisor of 40,419, and that decimal that I've got there. So we have to take each one of our populations and divide it by this standard divisor to begin with. So the 453,000 by this standard divisor gives us this number here. The 257,000 divided by this standard divisor gives us this number here. 156,000 divided by that standard divisor gives us that, and so on. So all of that is exactly the same as what you did for Hamilton's method. But with Jefferson, we're going to just drop the decimals off for our initial allocation. So 11.2 becomes 11, 6.3 becomes 6, 3.8, regardless of the fact that we might have always rounded something like that to 4, Jefferson's method says just drop it off, so it's 3. 5.7 is 5, and 3.8 is 3. Now, if we add these up, our initial allocation is 17, 20, 28. We are 3 short of the 31 seats. So, if we need to go up, which is what we need to do here, we need to go up in number. We need to divide. Our modified divisor needs to be smaller than this number here. Now, that may seem counterintuitive, but if we need to go up in numbers, we've got to go down with our divisor, because we're going to divide each of these by a smaller number and end up with a bigger number right here. So this sometimes takes multiple attempts, and I did try one number before this just to make sure it worked. But let's just try 38,000. That's less than 40,419. And if we do that one, and it might be that you have to do it several times to find that modified divisor. You might have to jump around a bit in between. Let's say this ends up being too low, then we might have to go in between these two numbers until we find one that works. And there's more than one modified divisor that will work. So I am now going to take the 453,000 and divide it by that new divisor, 38,000. So 453 divided by 38, I get 11.9. And really, I don't need to put all these decimals out here because we know that we're just going to round down. And then I'll take Grant, 257,000 divided by 38,000. And that gives me 6.8. Again, I don't need all those decimals. We can put them, but it's not as important as it was with Hamilton's. 156,000 divided by 38,000, except I can't type. 4.1. 231,000 divided by 38,000. 6.1. And then 156,000 divided by 38,000. Oh, that's actually the same number, isn't it? These two have the same population, so that will be 4.1. Okay, so let's notice now our second allocation, or our modified allocation, might be our final one. Rounding, or really just taking the decimal portion off of there. So 11, 6, 4, 6, 4. Now let's add that up. Maybe we've got 31. I have a feeling that we do. 11 and 6 is 17, and 4 is 21, and 10 more, yep, 31. That's our final allocation, and I can change that to final. So realize, if you are short seats, you have to go down from your standard divisor to find something that works, something smaller for your modified divisor. You might have to do it several times to get one that works. If you are over in number of seats, then you'll have to do the opposite. You'll have to go bigger than the standard deviation, or standard deviation. I teach stats, and that's what SD means in there. Than your standard divisor. You'll have to go bigger than your standard divisor in order to get it to work out. And you might have to try several times until you find a number that works out for you. And, if we had done this and we were still short one, we still didn't have enough, we'd have to go lower than 38,000. If we went over one, we'd have to go somewhere in between these two. So you do have to do a lot of playing around. That's the tedious part of these methods.